inside the atom. Right. What is atom about? So what is atom? As for Dalton's. So as for Dalton's atomic theory, as we have discussed the day. Okay, atom is as per Dalton's atomic theory. What are the state is one of the complex. So matter is consisting of only atom, which is the basic structure or basic unit of atom. Okay, so the basic unit of matter is basic unit of matter is atom, which is indivisible, indivisible. So this is the criteria here. Is correct? So for us, the discussion starts from this point. So for ages, so Dalton's time was very long. I think 1800s, so 1809 somewhere like that. So during this time and during whatever the equipment, whatever the facilities that were available those days, okay, Dalton could come to a conclusion that okay, matter means the solids, liquids, and gases which we know today, which we are seeing today, they are all composed of what is the only unit, basic unit, that is that it as atom. Okay, is that it as atom, and this atom is the building block of either solid or liquid or gas, whatever it is. Okay, so atom is, and it is indivisible. It is indivisible means there is no other substance or no other particle than atom which is the smallest. That means the smallest particle ever exists, could exist, okay, is atom. So this was whose opinion? Dalton's opinion or Dalton's statement. Okay, this was okay believed true for a few days, but scientists they keep on doing research, you know. They keep on doing research we discussed. So that means, so after a few days, okay, or during that time only, okay, Faraday, Michael Faraday, and one another scientist called J.J. Thomson. These people they were busy in their research works. Okay, Faraday used to conduct a few experiments called as electrolysis. Electrolysis. So, electrolysis means electrolysis. In biology, in your biology, somewhere you would have got this word called as lysis. Suppose amoeba, okay, or paramecium. Okay, you have this paramecium. So they undergo reproduction called as what is that one? Fission and fusion. Fission means what? Breaking down into two, no? So asexual and sexual reproduction, something you have there. So in that, this one body of amoeba gets divided into two, no? So it gets divided into two amoebae, amoebules or something. So that is called as fission, or that is lysis. Lysis. The word lysis means breakdown. The word lysis means breaking, Okay, breakdown. So here electrolysis means not our okay. Meaning what I am saying is meaning you can take it as same as in biology, but what is getting broken here is the compounds are broken. Here means suppose you know the day I told them gold, gold ornaments, gold ornaments to get polish, to get the polish. Another example also I say, okay, copper coating to the bottom part, to the bottom part of this, to the bottom side of bottom part. Kitchenware. Kitchenware means what? The utensils which you use in the kitchen for cooking. Okay? The utensils which you use in the kitchen for cooking, we call it as kitchenware. So here, gold ornaments get polished. So how do they do? Have you seen? They will take one vessel which contains a salt of gold. What is that? A salt of gold. Okay. Means the salt of gold means suppose for example here sodium chloride. We say that it is a salt of sodium. Copper sulfate. Okay. Copper sulfate. So it is a salt of copper. So like that they take one salt of gold. Salt of gold. And in that, if it is broken, so we can break this sodium chloride into sodium plus and chlorine. Similarly, here also Cu plus 2 SO4 minus 2. How can we break? By sending electricity. By sending what? By sending electricity. By sending electricity, we can break down the ions of a particular salt. Are you observing? Okay. So the process of what is meant by electrolysis? It's not definition. Listen carefully. So the process of dissociation. What is meant by association means what? Adding. Association means adding up. Dissociation means breaking down into parts is called a dissociation. Okay. So dissociation of or breakdown of or separation of a particular salt, a particular compound also you can say, a particular compound or a salt into its ions, into its ions with the help of electrolysis, with the help of electrolysis, help of electrolysis, or with the help, sorry, with the help of electricity, or by passing electricity is called as electrolysis. Okay. So if you want, I will write the okay, the method. Okay, the method of separating, separating or you can write dissociation, dissociation of a compound into its ions by passing electricity, by passing electricity through the solution, through the solution. So this is the definition for what? Electrolysis. No? Electrolysis. So this is the definition for electrolysis. So if you see the statement, the method of separating dissociation, separating or, oh here I have written or. Okay. So or dissociation of a compound into its ions by passing electricity through solution is called electrolysis. So who conducted that? He. So at the time itself, okay, electrolysis experiments were conducted. So he got a result that if atoms were not able to get divided, how could this gold atom or sodium or copper? See, copper coating is the bottom part. So that means you can see the entire vessel is made up of stainless steel, but the bottom will be coated with copper. How come? How could they do this? They can do this by electrolysis. Okay, copper salt there they two rods. One is positive rod, another one is negative one. Okay, we can consider that as electrodes. Electrodes. The solution is we call it as electrolyte. Okay, electrolyte, electrodes, and then electrolysis. Okay, so electrolysis means a solution of the particular salt will be taken. Whichever salt we need, that particular metal rods only we have to just in that one cathode and anode. We call them as cathode and anode. Okay. So positive ion what do we call? Cation. So the positive rod we call it as anode. Negative ion what do we call? Anion. And the negative rod we call it as cathode. Okay. So right. That we will discuss when the time comes. So here, if you have observed copper coating to the bottom part of each other, how is it possible? That can be, that is possible with the help of a method called as electrolysis. Many students are feeling oh, right. The process is electrolysis. So if atoms were indivisible, then how could this become possible? So this was the logic developed by Faraday. And Thomson also was busy in finding out whether atom could be divisible or not. So finally, after conducting many experiments, okay, after conducting many experiments, one day, that means July, okay, he could find that is in 1897. 1897. So, around 1897, okay. So, J.J. Thomson would find certain particles with a negative charge. Certain particles carry negative charge existed. Existed. During his experiments that he conducted with this vacuum tubes, okay, gas discharge. Okay. He used to conduct some experiments with the help of vacuum tubes. Okay. So there he could understood. Okay, he could understand that the particles were with negative charge. Okay. So they existed. So finally he found out that one. But okay, he couldn't name it. Okay, negative charge particles. But the name was given by electron. The name electron. The name electron to the negatively charged part. Negatively charged particles was given by another scientist. Was given by another scientist called Johnson Stoney. Johnson Stoney. So you can use it. So even though we don't remember this person's name, so anyway, who founded electron means so electron discovered by who means we will say it as J. J. Thomson only. Okay, students. So J. J. Thomson. So after this, in 1898, so he proposed one atomic model. He proposed a model of atom. Okay, he proposed a model of atom. That is what we call it as Thomson's model of atom. So finally, what happened to the theory of John Dalton? So during Dalton's atomic theory, we have studied that okay, basic unit of matter is atom. So by this, it has proved wrong, no? Yes or no? Yes. So in 1897 itself, okay, Thomson could found there are certain particles which carry a very small charge that is called as okay electrons. So the first subatomic particle that means where do these lie? They are lying within the atom. So what do we call them as? Subatomic particles. What is that? Subatomic particle. So the first subatomic particle that was discovered is what? Is electron only. Okay, the first subatomic particle that was discovered was electron. So then onwards, this race began. Means the race to explain the structure of atom. Okay. Electron discovered by whom? By J. J. Thomson. So immediately he gave a theory of atomic model. So in 1898, okay, Thomson's model of atom. Thomson's model of atom. He declared one theory. Okay? Model of atom. So, what is this theory? What does it contain? Let us discuss now. So finally now it is concluded. So we came to a conclusion that there are some more particles within the atom. Okay, that's right. There are subatomic particles. Subatomic particles. Okay. So subatomic particles. Among the subatomic particles, okay, electron is the first one to be. Electron was discovered first. So then afterward, so a race was started to explain the structure of atom or the model of atom. So what did Thomson propose was the atom will be like a spherical shape. That means it is in a spherical form. Or simply to say what is that is plum pudding. You know plum pudding? Plum pudding. Plum pudding model or watermelon model. Watermelon is what? The red color. So let us say discuss. So what did Thomson say is first one is So the entire charge, that means atom is spherical in shape. Atom is spherical in shape. Okay. So the entire atom consists of positive and negative charges. Okay. What is the second property? Okay. The entire atom consists of positive and negative charges. Negative charges. So again in this, how the positive charges are distributed and how the negative charges are distributed is what he is saying is, okay, total atom, the total atom is filled with positive charges with the and the negative charges and the electrons are distributed. The electrons are distributed randomly in like the seeds, like the seeds in the watermelon, red watermelon. So this is the thesis. Okay, this is the theory of the droplet. It is given by whom? It is given by J.J. Thomson. Okay, so J.J. Thomson's model of atom. What does it contain is, what is he saying is, the total atom is spherical in shape, like it is saying. So if you measure this as a atom, so somewhere randomly this will charges are distributed. So plum pudding model or otherwise, okay, to be little bit specific, I try to draw it. Okay. So here and all, these negative charges are, suppose this is a watermelon. Okay, seed. Okay, this is of red color. Okay, so this is like watermelon. Okay, this is the red color, which means protons. Which means, okay, protons were not found by the time. We say that positive charge. Red color, positive charge. Positive charge. Because okay, now what? Okay, let us elaborate this one. Okay, so what he is saying is plum pudding. You know, plum pudding. Some cake will be there. In that some what is gajus are kept there, like that, something like that. Okay, right. So we will discuss this one better. So what he is saying is atom is spherical in shape. What is spherical in shape? You know the sphere. Nice. So entire atom consists of positive and negative charges. What he is saying is the entire atom is actually that if you take a watermelon, red color watermelon, tarbuja, generally we call it. No? So in that red color is completely whatever we eat, that red color is there. No? So that is like that is positive charges he is saying. So that entire atom is completely made up of positive charges only. And where these negative charges are there? Okay, just like how see the total atom is filled with positive charges and the electrons are distributed randomly like the seeds in the watermelon. Seeds are very few. Seeds are randomly somewhere distributed like this. Okay, so these seeds are distributed. Okay, how these seeds are distributed in the watermelon? The same manner, in the same manner, these negative charges are present in an atom. So this is his conclusion. This is his conclusion. So he got Nobel Prize somewhere at the time for this. Many of his students and even his son also got Nobel Prize after that for other discoveries, regarding some other discoveries. But one another, okay, one of the student is, okay, Rutherford. Okay, there was a student called Rutherford among the students of this J.J. Thomson. Why? Because the drawback here is, okay, this is not a successful model. Because if total positive and negative charges are present, they will interact and that atom will collapse. So matter should collapse. We are not saying the matter is collapsing. Matter is existing. Matter is stable. We are seeing different things. No, these are all stable. So Rutherford got with this one. So he started one experiment. So he tried to do an experiment in which he got very astonishing results. What is that one? That is what is called as alpha ray scattering experiment, which is a very famous experiment in the field of science. The field of science. What to say that one is only people will be saying no. That is outstanding like that. Mind bending. So one of the experiment of one of the student of Rutherford, sorry, Thomson. Student J.J. Thomson conducted an experiment, with gold foil. Gold foil. Foil means nothing. One plate. They think as a plate, gold plate, thin plate. Okay. Gold foil, and alpha ray, source. So what did he do is, okay, he took a source of alpha ray in a tube. Okay. Source which emits alpha rays. Okay. So this is the source which emits alpha ray. Let us consider. Then what did he do is, he arranged a gold foil, gold plate, plate made of gold. Okay. Plate made up of gold, which is in turn surrounded by a detector. Okay. Surrounded by a detector. So what had happened is, he made this alpha ray from here to strike the gold particle right away, to pass through the golden. So what was the conclusion? So this was the experiment. Okay, conducted by J.J. Thomson, sorry, Rutherford. Okay, students, so this is the experiment conducted by Rutherford. Rutherford's Rutherford's alpha ray scattering experiment. Okay, Rutherford's alpha ray scattering experiment. So here, this is the alpha ray source, alpha rays emitting source. These are the alpha rays and the gold coin. Gold coin. And this is the detector. Detector plate. Right, students? So this was the experiment conducted by Rutherford. So to analyze this in a simple manner, suppose you can simplify this one like this. Okay, otherwise, draw simplified diagram to understand or analyze Rutherford's experiment. Okay. Suppose if you think these are all gold atoms, gold is solid, no? So the atoms will be very close to each other. Think that these are all of same size. Okay. All right. Now these alpha rays are being passed to these gold atoms. Okay, students. So Rutherford's alpha ray scattering experiment. So what did he take? So based on whose assumption he started the experiment? Based on Thomson's model. Thomson's model. What are the assumptions of Thomson's model? So Thomson's model. So the main one is entire atom is entire atom is made of positive charges. So this is the basic idea. Okay. Then negative charges are distributed within the atom, within the atom. So remember this one carefully. While we analyze this experiment. Okay, students. Now, so this is a trend creating. So what to say that one? Revolutionary experiment or which revolutionized the field of revolutionized revolutionized field of science. Field of science. That means such a great experiment it is conducted by whom? Rutherford. Okay. So that is Rutherford. Okay. Right. Rutherford, one of the student of Thomson. So we took a gold coin, we took the alpha emitting source also. Okay, so this is the source we kept here, and these alpha rays contain diversity charge. Alpha ray is double positive. Is a double positive It is a dual positive charged particle. So it is a very positive charged particle, and the mass is 4 times that of hydrogen. 4 times that of hydrogen. Then, like that, what he did is he took a gold foil, okay, or gold plate, something like this. Okay, gold plate. Means suppose you think that this is a gold plate. Okay, so the rays should pass through the gold plate. Okay, like this. Like this. Okay, so he made this gold. Okay, he made this alpha rays to pass through the gold plate. Okay, so most of the rays have passed. Then he came to under. He wanted to see whether the manner. He wanted to see the manner how the alpha rays are passing through the gold plate. Means how many rays? Suppose nearly some 20,000 rays will be considered. 20,000 rays for at a time. Okay, per minute or something. Okay, right. So we'll come to this one later. So, and he kept some shining material around this detector plate. Okay, this is called a detector plate. This is detector plate. This is the alpha rays, and this is the gold foil, and this is the alpha ray source. Okay, students. So, listen carefully. Now, afterwards, when he finished the experiment, when he finished the experiment, he was astonished. That means what he thought was completely wrong. What he thought was completely wrong means here, if you consider the Thomson's model of atom. So what is the main postulate? Entire atom is made up of positive charges. So that means if the entire atom is made up of, this is one more atom. It is each circle which I have drawn here is representing one gold atom for our better understanding of the concept. Okay, these are all atoms, gold atoms. Okay, so he started with quantum function. The rays should all come back. The maximum rays should come back. Means you should see scintillations here. You should see the rays hitting this part of the detector plate. But to his astonishment, to his wonder, he saw most of the scintillations here. Means most of the rays that were showing like spark. Okay, the sparks we could see here. Okay, and the second thing, negative charges are distributed within the atom. No, he couldn't find any attraction. Okay, so now I will rub this and draw the pattern to understand this experiment of Rutherford to analyze or to understand the model of atom. To understand the model of atom. Model of atom. So suppose if these are the rays passing through these atoms. Okay. Okay, students. So, what was the analysis? Okay, these are alpha rays. We can these are the alpha rays. So we denote alpha with this alphabet. Okay, Greek letter. Okay, alpha rays. Right, students? So he conducted the experiment and he came to a conclusion. So what he found was these rays, maximum majority, nearly out of 20,000 today, nearly more than 12,000 rays passed undeviated. Undeviated. Deviation means what? turning, bending. Okay, turning any side like this or like this. So undeviated means moving straight. Okay, undeviated. That means they did not change their path. The rays did not change their path. Suppose you think of, okay, you think of taking a stone and hitting towards the wall. What will happen? It will hit the wall and come back, or either otherwise it will fall there, or fall after a certain particular distance. Okay, beyond the wall. Suppose here we have a wall. So if I take a stone or a ball, whatever it is, so a small pebble like that, and if I throw onto the wall, surely it hits the wall and falls there. It will fall down. But think of a fencing. Think of a fencing with huge gaps. Are you understanding? Think of a fencing. You know fencing. What is a fencing? Something that is made up of a wire or thread or rope. Okay, to indicate some border. So fencing generally in field, in cultivation. That means agriculture fields you would have seen, no? Generally with the help of iron they will make a fencing. Okay, not that fencing. Fencing consisting of both horizontal wires and vertical wires also. But what I am saying is the gap is big. The gap is big. So fencing. Like this. This gap is big, no? Are you able to see? Ah, right. So fencing is such a big gap. Okay, so the gap is more here now. So if you take or if you throw stones like that, means the stone, the possibility of stone to fall down is very less. That means there is more possibility of the stone to pass through the gap. Pass through the gap. Sir, are you able to understand? Okay. Once again, you start from the beginning. Okay. So first of all, Rutherford is one of the students of J.J. Thomson. He wanted to verify the thesis given by his teacher, that is J.J. Thomson, saying that the entire atom is made up of positively charged particles. We don't know. At the time, the positively charged particle is called as proton was not invented because proton was invented by Goldstein in nearly 1920. Positively charged particle called proton and the name proton was given in which year? 1920. This is happening in 1913. This is around 1913, 1913. Proton was discovered almost 1920, 1920. Okay. So within this, all the atomic models were declared. Okay. So this is Rutherford's model. After that, Niels Bohr. After that, Arnold Sommerfeld. After that, Max Planck. Planck's quantum model. So everything was over by 1917. All the models of atoms came to existence. Okay, but after that only in 1920 the positivity charge, because here to explain this atom mostly they are considering electrons only. The discussion was completely based on these electrons only, electrons from the atom nucleus. Okay, so here most of the discussion is regarding these electrons, and then after 1920, then again neutron, one another particle, subatomic particle, neutron was discovered in 1932, 1932 by Chadwick, James Chadwick. Okay, so electron was discovered by J.J. Thomson, proton discovered by Goldstein, neutron discovered by James Chadwick in 1932. 1932. Okay, right. Now we come to this. So here alpha has emitted a few rays came back also. A few rays came back, but most of the rays, majority of the rays, see how many? Majority. No? So majority of the rays did not have any deviation. Majority of the rays undeviated. These are undeviated. And a few rays they went like this. That means they would have hit. See, they would have hit a huge positive. See, you know very well that if you take two magnets, okay, and if they are repelling, you will in your lower class you would have studied. Two like poles, north and north, or south and south, they will repel back. Similarly, here also the charge is getting repelled. Charge is getting repelled means what is the meaning? There it has interacted with a positive charge. There it has interacted with a positive charge. Okay, so positive charge. So this is already a dipositive charge. Alpha rays means it carries 2 units of positive charge, right? So here already it encountered with some another positive charge. Means see here, if it is building like that, it would have come across a positive charge only, no? Okay, so then only this can happen. Otherwise, because this is the proof. Because you could find the facts here. Facts here means some of the rays came like this and some of the rays came like this. Here, this part. But majority, see here, how many, this many are there? Mostly out of 20,000, for example. Just a rough number for our better understanding. If you think that 20,000 rays were passed like this, 12,000 rays came like this. 12,000 rays came like this. Means they came undeviated. They did not deviate. That means I told them take a stone and throw to a fence like this. Okay, if you are throwing a stone, people. Okay, throw a stone and fence where the gap is more, the stone will pass very easily. Like that, these alpha rays have passed through the gold plate without any deviation, without any bending. Okay, without any deviation, without any bending. Okay, so that I have represented here. Same thing is here. Instead of this plate, I have drawn the atoms of gold. These are all gold atoms. These are gold atoms. Why gold atoms? He took a gold plate. He took a gold plate for doing this. He could have taken silver also. He could have taken copper. If you change the plate, there is no difference. Okay, no difference. Here the difference is this one. Our understanding what is happening is okay. So most of the rays, okay, came undeviated. Only a few were deviated with very huge more angles, and some of them had head-on collision. Head-on means head-to-head collision, such that they went back like this. They completely went like this. Okay, they completely reverted back. You can say they completely reverted back. Understood? Right. And some of them they would have got this side-on collision. Side-on is see, if this is a positive particle, this ray is passing at the sideways. So not like this, but just a sideways like this here. So the charge which it is influencing is very less. So its deviation is little only. Little only. Head on means it will come like this. Head on means it will come like this. So at a sideways, okay, little sideways, it is little bending. Little bending. Understood? So this is the analysis of what experiment? Analysis of Rutherford alpha ray scattering experiment. So alpha ray scattering experiment. So after this, what is the conclusion given by Rutherford? I'll write it on the board. Okay. So the conclusion is so most of the atom is empty. Most of the atom is empty. Okay, see, if we remember Thomson, okay, Thomson's statement. Nearly 90%. So, first one, I will using students very, very important. Postulates of First we will analyze his experiment results. Okay. Okay. Conclusions after the experiment. Conclusions after the experiment. So conclusions after the experiment very easy. So maximum most of the particles, most of the alpha ray particles passed undeviated means passed through the gold point. Okay, then therefore most of the space in atom most of the space in atom is empty. Most of the space in atom is empty. Why? Because maximum rays have passed like that only. Means they passed undeviated. They did not deviate. They did not feel the charges. See, if it is completely filled with positive charges, all this would have come back. No? All this would have come back, but that did not happen. So they passed undeviated. Means it is almost empty only. Okay. Then third one. Very few rays deviated, slight deviation means which means the positive charges which means these rays had sidewise collision with the positive charge with the positive charges with the positive charges. Then fourth one you can see some of the rays came back. No, some of the rays reverted. Very few rays reverted back. Very few rays reverted back due to head-on collision. So, due to head-on collision, they have reverted back means at this part of the in the center. That means if you consider this as an atom. Okay, you consider this as an atom, and most of the space is empty, and the entire positive charge is situated at the center, and this is called as nucleus. Okay, this is nucleus. So that's why we call the model proposed by the model proposed by Rutherford afterwards. It is named as nuclear model or planetary model also you can call. Okay. So what is the conclusion here? First conclusion is most of the alpha rays are undeviated. Most of the alpha rays are undeviated. So that means most of the space in atom is empty. 90% of the space in atom is empty. Next one, very few rays deviated slightly, and a few more deviation also. So for this rays and this rays, the reason is head-on collision. Okay. So for this rays, they also encountered a huge positive charge. So that means what he concluded. See, very few rays reverted back due to head-on collision, which means okay, there is a huge charge. That means they have hit a very huge charge. Hence they have reverted back in the opposite direction, head-on collision. So that means what he concluded is the total positive charge is confined to the center of the atom. The total positive charge, like what who said? Thomson said, is not completely spread in the atom, but it is confined to a very little are mostly nearly 1 lakh times. The volume of nucleus when compared to the volume of atom is nearly 13 lakh times smaller. Or very small, you can think. Okay, leave that sizes. So the entire positive charge is not spread throughout the atom, but it is confined only to a very little part called as center in the atom. So the atom, the particles are charged particles are positively charged particles are limited only to the center of the atom. So he gave this model. So then Rutherford explained his model.